Okay, we can start. Hello, everybody. My name is Mauro, and I'm solution architect and head of developers in DOS Group, one of the sponsors. You can find our colleagues at the desk and ask everybody you want. Just want to start with some simple question. Who of you knows about continuous integration? Okay, continuous delivery? Well, perfect. Docker and Kubernetes? Did you use that in production environment? Oh, less than that. Okay, and Jenkins? Well, perfect. It's still the most used. Perfect. Just before start, how I think to present this topic. First part is a presentation, and if we have enough time, I would like to have a live demo of the tool, but I try to be fast enough. Okay, once upon a time. So this story started a long time ago when I was working for another company, lastminute.com, and just to give you some context, it was a company, medium company, 100 people, more or less, and it was a mess for the development side point of view. It means that there wasn't a real continuous integration. The build jobs were made by volunteers. Nobody cares about the build status, so often the build was broken and nobody cared about that. So it was a mess. And how was the product? It was a big monolithic application written in Java. The code base was growing a lot with patches and so on. So we usually performed 2 or 3 releases per year. The deploy duration was 2 or 3 months. So before say, okay, we've closed this deploy, there were a lot of parallel branches because all the new features were developed in different branches. So there was the problem of merging and integration. And urgent features were deployed straight in production and with all the risks and so on. Who of you experienced something like that or is in the same situation? No. Don't be shy. It happened to everybody. So then we say, okay, we have a problem. Then what's the best solution we can find at the moment? Then, okay, let's go to microservices. So this was the situation. Who of you tried this kind of migration? Was it a mess? Okay, the same for everybody. So also with the technical migration to microservices, then we performed an agile migration. We had many teams. We tried to start with all the good things we use today, like okay, Scrum for the methodology, for the processes, TDD as a practice, a real continuous integration, and related to the microservices. But what about continuous delivery, deploy, and so on? Well, there was an anarchy. So all the teams they had their own way to deploy their project, their application in production. Somebody created some scripts, but okay, everything was custom and it works with a lot of patches. I don't tell you what was the result. So at the moment, we needed a superhero. So somebody who take care of everything and try to find a way to clean up this mess. So our first goal was this one, so one job to rule them all. So it means that first of all, we need a standard way to deploy our application in production and try to recycle the code. So instead of reinventing the wheel all the times, find some common libraries or common scripts. So the first step, just to give you some context, our code base was written mainly in Java, and it ran it on Tomcat that was installed physically on the server, and we had a lot of different server with different configuration, a lot of way to configure this application. So everybody invented his own way to configure everything. Our tool was Jenkins at the moment. We tried to use it as we should use, and we used it for the continuous integration and also to orchestrate the deploys. Who of you knows Jenkins, not only for continuous integration, but also for continuous deploy, Jenkins pipelines, and so on? Well, perfect. Who thinks that is not the best tool to do that? Okay, the door is there. You can. Yeah, I'm kidding. No, I know there are many other tools, but I think that all the principle we use can be applied to other different tools like Circle CI, GoCD, and so on. It's vintage, but at that time was the only one tool on the market, so we started using that, and then what we did, we said, okay, we can create our custom bash script to deploy something in production. So our script connect via SSH to the productions, to the server, and then perform the deploy as we did manually before. But there was the first problem. So we cannot access directly to production server for a security reason. And then we had to find a different way, some workaround to achieve our goal. So we tried with dependency inversion. The principle is the same. So instead of copy artifact on the server, we tell to the server, okay, download the artifact from a trusted repository. So we used Nexus that was visible by the production environment, not public. And in this way, we avoid to access the server to copy something. Instead of copy or change the configuration to the remote server, we tell to the server to upgrade his own configuration from a trusted repository, the same way. So instead of using Nexus, we used the Git, but the principle was the same. And instead of execute remotely commands, because it's dangerous, we tell to the server to deploy itself. So basically, we invoke a script, so an URL. He understands that he has to do the process to deploy the application. So stop the Tomcat, copy the artifacts, copy the configuration, and then restart again. And it worked for the first time. And we suppose we solved all our problem. But the assumption is the mother of all the mistakes, because what happened? Simply, after a couple of weeks, somebody told us, well, we need to deploy a jar, not a WAR file. How can we do that? There's no problem. We simply can change our script, and it works. So we did it, and this was the result. So we broken everything. Well, how can we prevent these kind of issues? We need a way to test our code, and we need to run the test automatically after any change. So we had to find a way to use TDD for the scripts. But okay, the question is, why should I test my final pipeline script? So it's like code test. test code only with end-to-end tests. It's expensive. You have to test everything all the time. It's a mess. And then we have to repeat the same test for all the pipelines. So it's so expensive. And in the meanwhile, what we did, we improved it and moved it to Spring Boot and then Kubernetes, Docker and Kubernetes. Then we had a lot of pipeline that need to interact with all the environments, all the technologies. So the pipeline script were growing a lot, and so copy paste has a lot of problem. So we had to find a way to create some abstraction, some common libraries, something like that, to make it easier to implement by the developers. So here born another need to remove duplication and make pipelines simple for the developers, but robust at the same time. So our goal was also to give the tools to the developers to create their own custom pipeline, avoiding to rewrite most of the code. And we found that Jenkins has this wonderful thing that is global shared libraries. Who of you knows it? Okay, and I try to explain what it is. Before that, why? Because this is a way to avoid reinventing the wheel. Because these global shared libraries are libraries that are loaded by Jenkins, basically at startup time or at runtime. I explain it later, and can be used as you like, as you prefer. So they allow you to define your own library to share with all the pipeline script you use. So basically, it's like you create a function or a class and you use it, and it's so simple. So they allow you to reuse your code, but most of all, you can test your libraries. And now I show you how to. How to use them. There are two ways, basically. The first one is using the workflow libs. This is the old way 4 or 5 years ago. It was the only one. And these libraries are on the Jenkins file systems, and they are loaded at Jenkins startup. But they had some problems because of a loading procedure wasn't very well. So sometimes you need to restart Jenkins to reload your function, and then it's a problem if a lot of people is using Jenkins in that moment. So you can stop the production the productivity for for a lot of time. And we followed this way because we were brave, and that was the only one way. The modern way is using the annotation library, so you can load it dynamically directly in your pipeline. So you create the annotation library, you put the URL, and you load it. Usually, all these global shared libraries are loaded as a closure by Jenkins. They are written in Groovy. And now I am showing you this way. Okay, what's the structure? It's simple. It's relatively simple. So we have the resources, just like a Java project, more or less, a Maven project or a Gradle. You can have the resources that are static data. You can load if you need some kind of configuration, everything you want. The vars folder, which can contain some Groovy script that are simply functions. And then the source folder that contains real Groovy objects. Now I show you, this is a common structure. It's valid also for workflow libs or library, it's the same. So what was our first step? First step was to move our shared code inside dedicated function. It was this, the function inside the vars folder. This folder contains functions that are loaded at startup of Jenkins, and you can use it inside your pipeline, simply calling them by name and pass your parameters. And they are shared globally, so you can call them whenever you want, in all the cases. But what was the problem? You can test it on your own PC, your locally, and you can do that because they are only in Jenkins, and because if you put some Jenkins specific commands, so Jenkins specific calls inside your functions, you cannot run it on your local PC. Then let's do object oriented. So we used the other one, the source. There are the groovy objects, so the Java classes, and in this way you create really real classes, and you can do all the things you need. Why? Because we were clean coders, and we hope are still today clean coders. We want to follow solid principle, design, dependency injection, and so on, and most of all TDD. So how we started? We started easy with a simple class. As example, this one to encode parameters. Here we are our class with an URL encode, URL decode, and it's really simple with the unit test. I don't want to explain the test, but it's really easy. Test for the encoding, for the decoding. And first approach worked because it was so easy. It was so easy because we didn't interact for this function, for this class, with the real Jenkins objects. But what about, I don't know, if you want to interact with the console log or with some plugins of Jenkins that you want to use. You don't have a reference of that. And it's in Jenkins are called steps. It's a common variable that contains everything. So let's start using this. But what was the problem? You can't access it inside Groovy classes. What I mean, if you write your own pipeline, you can write it inside the Jenkins interface. You can create your function, create your classes, and then call some Jenkins functions like echo, error, and everything you want. But you cannot access from Groovy classes defined in global in a global shared libraries. So it simply doesn't work. And second was how can you test it locally on your own PC if you don't have Jenkins? Then you have to install your own Jenkins server. What happened? Hey, sorry. Okay. So our idea, we spent a lot of time. So a lot of time has passed before we found with this wonderful idea that was pass these steps reference in the constructor as a constructor parameter. Why we didn't thought it before, I don't know. We simply didn't know that we can have this object that contains everything. So let's move to another example. In this case, using implementing an abstraction around the HTTP client. So our HTTP client simply needs the HTTP request of Jenkins, and we pass we call Jenkins as a name, as a reference, and then we can implement our logic and use it. How can we test it on our local PC? Simply using mock object. Everybody of you knows mock objects, I hope, yeah. So the fake was the first stamp. I didn't find a stamp with mock, so I used that one. But it's almost the same principle here. Let's show the real example. We simply have our test code class, and we override the definition of the Jenkins object. Simply define this HTTP request and defining the method and the response we want to mock. It was so easy because it was groovy. So it uses groovy, so it was quite simple to do. Okay, now let's try it in production to see how it works. We have all our unit tests and we have integration tests because we are mocking Jenkins. So let's try it in production. And we had some problem. We had some problem because the behavior of our mock object wasn't the same as of the real Jenkins instance. Then for unexpected behaviors, we had everything was broken, pipeline broken from everybody, a lot of time people wasn't able to deploy in production, and so on. And then the third need was to have integration tests that should run locally and on Jenkins. And this was another challenge because you have to write, try to find the abstraction to run all of them on the same, using the same code on different environment. But I show you later how we did. Just let me show an example of integration test. We simply create an abstraction, so a method call around our tests, and we run it on the Jenkins instance. As you see here, this is the integration test. Then what we need is just to create a pipeline in Jenkins that run code like this and pass the Jenkins reference as a parameter. So, as I said, locally we use fake implementation. So we pass a fake instance of steps mocked by our needs. The fake object returns the expected value, so the test can pass also locally. And the fake object can perform the same action with different implementation. As example, for the HTTP request we have seen before, you can implement also with native Java library with the HTTP URL connection and perform real call and receive the value you expect. If you run that using the same the HTTP request of Jenkins, then you can reach the same receive the same result and so reach the same goal. To run on Jenkins, as I said, the real Jenkins step is passed as a constructor parameter to the test, and the real action is performed. So in this case, the HTTP client uses the HTTP request inside Jenkins using this form. It's so easy. This is simply our pipeline that is split in two, because the first one execute the unit test simply with a Gradle build or everything you want to use to build your code, and the second part execute the integration test. But let me show you a fast demo. I think I have time. Yes, see, we have enough time, so I can run a little demo if I am able to do that. Let me try. So I show you some code. Let me mirror. Oh, wait. Wow. I don't really like this one, but let's increase the font. Sorry for the latency. Okay. Can you read that, or is still too little, too small? Okay, perfect. Just let me show you. This is our simply. Well, this is fun. So the echo logger. This is the echo logger test because we created. This is our Jenkins echo logger because we want to simply print something fancy inside the console, and this was a simple abstraction around the echo call of Jenkins, the echo method of Jenkins. So we simply written our object. This is our groovy class with all the implementation we wanted, and then this is the test. It was so easy. It's not too complicated. Just to check if everything is printed as we expect. We needed to override here our Jenkins steps. So because this is the parameter we expect as the steps. And so here we can run our test and it still work, I hope. So there is the demo effect. Hey, where you are? Okay. Okay, this is the output because we added some logs. So this is the print, and then this is the output with these fancy characters. But how can we run it on Jenkins? Okay, now I run it on my local machine, but I have to run it on Jenkins. So this was we had to put this integration tests inside the source code because otherwise Jenkins is not able to read it because it reads only in the source folder, not in the test one. And this is the implementation of integration test. It's just one class that need to be invoked, and inside the invocable method there is the call to all the tests, all the test classes that are the ones we have seen before. Let me show you inside Jenkins. So, can you see it? Okay. Please don't steal my password. So this is the pipeline content, and simply we invoke here in the stage of the integration test, just Nico, and then we load the library defined here. Jenkins download automatically the library from, in this case, is GitLab, but you can define a simply your own Git repository. Downloads the library, it loads it here, and then you can run this test. So simply load integration test.invoke all. And if you are lucky, so the build was quite always blue, so I hope it works. And I'd like to show you the result of the build. Oh, well, okay, the Wi-Fi doesn't help me. I show you the output of the previous one. So this is the demo effect. Simply download everything, then build the project and run the unit test, and then the last step is to run the integration test that called everybody. And here you can see all the message we have seen in the unit test. In the integration test we performed locally, and this is the result. So it works. Now, if you want, you can add all the abstraction you want, everything you want. And you can simply use your own libraries in this way. You define here, you import the library, and then you instantiate your own object, and you create your pipeline using a common method, a common tool, and so on. So let me go back to the presentation. So, just to recap, what we have seen. We have seen how to write simple unit tests on libraries and abstractions, how to write complex tests mocking Jenkins steps, so the core library of Jenkins pipelines, how to write integration tests, how to run unit tests locally and on Jenkins, simply a Gradle build, and how to run integration tests locally and on Jenkins. But most of all, I show you that there is no silver bullet. So sometimes you have to accept the compromises. What I mean by compromises, you can simply have the same code to run it everywhere. In this case, you have to do some tricks to run it on Jenkins and so on. So other tricks were, as example, just to test the HTTP client, simply, okay, let's go directly Jenkins, so we are sure that it works. And basically, in the example, there was I was using localhost and calling API. So basically, I'm sure that it works. But why we did everything, all this stuff? So because I think that most of you still use the pipeline, writing the code inside the Jenkins interface instead of using the Jenkins file and so on. Because the company was big. There were 100 of developers, and so if there is something wrong, something that doesn't work, the company is stuck. Nobody can deploy in production, because at the end, this was the only one way to deploy something in production for some regulation and some other reason. Teams has different needs because of different projects. So in this way, you have a library that solves 90% of the problem, and they are stable and people can use it. But in this way, you can simply customize your own pipeline and create your own libraries to run the pipeline. So this was cool for developers. And tested and well-structured code encouraged the people to customize them, because the company was big and was growing. There was only a few people that handle all this stuff, me and a colleague of mine, and we were really stuck because we have too much work to do. In this way, if you have a safe environment where people can play, they are encouraged to contribute, and people simply started the simple pull request as you do on GitHub, and it worked. It was working. People started to contribute, and all the libraries were growing so for the new feature coming from Kubernetes, for some kind of regulation born for, as example, PCI and so on. And then that's all. Some questions?
Thanks to the speaker. If you have questions, please say to the microphone. Any question?
Oh, everything was clear. Or simply everything was a mess and nobody understood nothing. And
No questions?
no questions?
Okay, let's thanks the speaker again.
Thank you very much. There are some libraries you can download from GitLab, so just to start playing, and there are all the references for the Jenkins shared libraries and so on. That's all. Thank you.